Hello, my gems. Welcome to our midterm review video. So as we go through here, what I've done is I've kind of picked like a couple of the really key components that maybe I think you may have forgotten. And so what's going to happen for this video is I'm going to go through an example problem. I'm going to do one out for you, and then I'm going to have you pause the video and I'm going to put a new question up and you're going to try the new question. So you're just going to follow along here for the we do problems. You can choose to do them or not. It's kind of up to you, but then when it gets to the you do problems down below, that'll be the ones that I am looking for to grade. So let's get ourselves started. And please ignore my awful manicure. Really need to get that fixed. But okay, let's get rumbling. So number one, we're going to start by graphing a piecewise function, your fave and my fave. So piecewise function means that it's going to be smaller pieces that make up one larger graph. So let's start the first one. My first equation is x plus 4, and it occurs every time my x value is less than 1. So I'm going to do this in my orange color here. So what I'm going to do is I'm going to pick x and y values that are less than this 1 value. So if I pick the number 1, I plug it in. 1 plus 4 gives me 5. Then I pick a number less than 1, that would be a 0. So 0 plus 4 is 4. Then another one would be a negative 1. If I plug that in, I'll get a 3. Now, because it is less than 1, that means at the 1, I'm going to have an open circle. And everything else is going to be a closed circle. So I'm going to graph it. 1, 5 is an open circle. 0, 4, negative 1, 3, and so on and so forth. So here,
Mr. Arthurus, can you please call extension 2095?
Awkward.
Mr. Arthurus, please call extension 2095.
Well, that was awful. Way to ruin my video. Okay, now second one. Anything that I plug in is going to give me out an output of 2, and my x values are going to be between 1 and 4. So it's going to be greater than or equal to 1, but less than 4. So I'm going to pick numbers that are between these two. So if I pick numbers between 1 and 4, that means I'm going to go from 1, 2, 3, and 4. Now, no matter what number I pick, my output is always going to be 2. So all of these values here are 2's. Now it says x is greater than or equal to 1. So at the 1, I'm going to have a closed circle, closed circle, closed circle, and then it's less than 4, so that's an open circle. So now I'm going to graph it. So 1, 2 is a closed circle, 2, 2, 3, 2, and 4, 2 is my open circle, and that's my second piece. Okay, and now my third piece, again, doing the same thing. I'm going to pick numbers that are greater than or equal to 4. So 4, 5, and 6. So if I plug in 4, 4 minus 5 is negative 1. 5 minus 5 is 0. 6 minus 5 is 1. And it's greater than or equal to 4. So at 4, it's going to be a closed circle, closed circle, closed circle. They're all going to be closed. So 4, negative 1, 5, 0. 6, 1, and I'm going to continue. So there is my first piecewise function. So now you are going to graph the piecewise function that is listed here. So go ahead and pause your video and give that a try. Okay, now number 2, we are going to write the equation of a quadratic parent function that has been transformed in some way. So transformations are going to be really big on this exam. So if I'm looking at a quadratic parent function, a quadratic parent equation is f of x equals x squared. And I'm going to transform this equation in some way. Now remember, when you are inside the parentheses, that's when you go left and right. And when you are outside the parentheses, out over here, that's when you go up or down. So I'm going to use that to help me answer these questions. So if I take this graph and I shift it 3 units left and 1 unit up, my equation is going to be, so I'm going to the left, so that should be inside the parentheses. So x, and because I'm going to the left, I'm going to add the 3. Close my parentheses and I square it because it's a quadratic, and then 1 unit up, that's going to go on the outside of my parentheses, plus 1. Easy peasy. So now let's do the second one. I'm going to vertically stretch by a factor of 2 and reflect across the x-axis. So if I'm vertically stretching, that means the number in front of the x, that's what is going to either stretch or compress my graph. So if it's a really big number or a whole number, my graph's going to get super skinny. And if it is a fraction, my graph is going to be compressed, it's going to be pushed down, it's going to get nice and fat. So mine is a whole number here, which means I'm going to stretch it. It's going to be smaller. And reflecting across the x-axis. So if I think about a graph, the x-axis is over here. If I flip a quadratic across the x-axis, that means it goes from a happy face to a sad face. Or essentially from a sad face to a happy face. You just do the opposite. But since I'm going from the original quadratic parent function, it's a positive, so I'm going to make my graph a negative. So my equation's f of x equals, so reflect across the x-axis means make it a negative. Now I'm not shifting left or right, so I don't need anything in the parentheses other than the x. And then I'm going to square it because it's quadratic. And then that's it. It doesn't get shifted any other way. Oh, I'm so sorry. Whoops, I forgot my factor of 2. That means I should have a 2 right here. So this is going to stretch my graph and reflect it. And then I'm not going left or right in any way. So that's my final equation. So now you are going to try number 2. So take a moment, pause the video, give it a try. Okay, now, excuse me, for our number 3, we are going to divide our polynomial, your fave and mine. So there are 2 different ways that I've taught you how to divide. I've taught you both with long division, and I've taught you with the box method. So you can do either one here. I'll do an example of both, and you can choose whichever one makes your heart happy. So I'm going to divide this by this. So this one down here is my denominator. That one's going to go on the outside. So I'm going to start over here with my long division. So I'm going to start with 5x minus 2 on the outside. Now, when I put my equation in here, I need to also make sure I have placeholders for every x value. So I start with an x to the third. I don't have an x squared, so I need to make sure I put a 0 for my x squared. I have an x, and then I don't have a constant at the end, so I need to make sure I put a 0 for my constant. Now I'm going to say, okay, how do I get from 5x to 25x cubed? Well, all I have to do is multiply by a 5x squared, so I'm going to put that above the x squared. So 5x squared times 5x is 25x to the third. 5x squared times negative 2 is negative 10x squared. Now remember, it's long division, so I'm subtracting. So these 2 will cancel. 0 minus negative 10 is a positive 10x squared. And then I bring down my x. Okay, now I say 5x times what gives me 10x squared? Well, that would be a 2x. 5x times 2x is 10x squared. Negative 2 times 2x is negative 4x. And again, I subtract. So these cancel. X minus a negative 4x is 5x. Be careful with those negative signs, and I bring down my 0. Now, 5x times what gives me 5x? That is a positive 1. And now this is a constant, so everything else that's going to be left over will be my remainder. 5x times 1 is 5x. Negative 2 times 1 is negative 2. So now the last part, I subtract. These 2 will cancel. 0 minus a negative 2 gives me a positive 2. So my final answer is 5x squared plus 2x, oops, sorry, 5x squared plus 2x plus 1 plus my remainder. My remainder is 2 over my denominator. So 5x minus 2. So this is my final answer. Okay, so if you liked that way, you can do it that way, or you can also do it by the box method, which I'll do right over here. And you'll notice I'm still going to get the exact same answer. So again, this part over here is going to go on the outside of my box. Okay, first number I'm going to put on the inside of my box is my very first number, 25x cubed. And I say, okay, 5x times what gives me 25x cubed? Well, that would be 5x squared. Then I multiply 5x squared times negative 2. I get negative 10x squared. Now, I need my x squareds to add up to be the x squared in this equation. Well, there isn't an x squared there, so I want these two to cancel. So since this is a negative 10, I'm going to make this a positive 10x squared. And now I do the same thing. 5x times what gives me 10x squared? That's a 2x. 2x times negative 2 gives me negative 4x. Again, I'm going to do the same thing. I'm going to go diagonally, and I want to figure out 4x plus what is going to give me a positive x. And so if I put those together, I get a 5x here. So when I add these two, I get a positive x. So now I go 5x times what gives me 5x? Well, that would be a 1. And now just again, just like what I did before, because I wrote a constant, the rest of this is going to be my remainder over here. So 1 times negative 2 is a negative 2. And then my last step is, well, I want it to add up to be my constant. I don't have a constant, so my constant is 0. So a negative 2 plus a positive 2 is going to give me a remainder, a constant of 0 over here. So again, just like my same answer that I got for long division, my final answer is 5x squared plus 2x plus 1 plus my remainder is 2 over 5x minus 2. So you can see no matter which way you decided to do it, you're still going to get the exact same answer. So you can choose to do whichever one that makes more sense for you. So now your problem here, you're going to divide that polynomial. There might be a remainder, cough, cough, hint, hint. So take a moment, pause the video, and give that one a try. Okay, now we are starting example number 4, which is a little bit of factoring. And so we're going to factor our polynomial by grouping. So when you've got 4 terms, you can group them as the first 2 terms and the second 2 terms, and then you can factor them individually that way. So the first thing I'm going to look at, though, is I'm going to look at my numbers here, and I'm going to say, okay, do all of these have a greatest common factor in common that I can divide them all by? And the answer is, yeah. I can take an x out of all of them, and I can take a 3 out of all of them. So I'm going to start by taking that out because that's going to make my life way easier. So if I take out a 3x times a 2x cubed gives me 6x to the 4th. 3x times a negative 3x squared gives me negative 9x cubed. 3x times a negative 12x gives me this term, and then 3x times a positive 18 will give me a 54x. So now I've already taken out one greatest common factor. That's going to make my life way easier. So I'm going to put a line down my 2 terms here. I'm now just going to focus on these 2 terms together. So if I look at just these 2 terms, just these 2, I'm going to say, do they have a greatest common factor? And they do. So I can take out an x squared. If I take out an x squared, I'm left with a 2x and a minus 3. So that's my first one. Now I'm going to do the same over here. Does negative 12x and 18 have something in common? Well, yes, I can take out a negative 6. And then I'm left over with a 2x and, again, a -3. So now if I look over here, I go, oh my gosh, look at that. These two are exactly the same. So those two are a greatest common factor. So I can also pull those two out. So now my answer is 3x, because that was my original one. I've got the greatest common factor of 2x minus 3. And I now have x squared minus 6. And there I go. I have factored my equation. And if I asked you to find the zeros, you would set each one equal to 0. But I didn't ask you that, so you don't have to do it. So there's your answer. Okay, so now you're going to pause the video, whoops, and you're going to try that problem. Okay, for number 5 now, we are going on to a new little topic here. We're going to talk about explicit and recursive rules for nth term in the arithmetic sequence. So if it's an arithmetic sequence, remember that means there's some kind of common difference, that it's like a pattern that I'm adding to it every single time to get the next term. So the first thing I want to do is I want to make sure, is this a pattern? So to get from 3 to 7, I add 4. 7 to 11, I add 4. Add 4, add 4, yes. So it looks like my common difference, my D value, is a 4. So that's great. Now, the recursive formula is probably the easier one. Recursive has the brackets, and all you have to do is state what your first term is, your A1, and my first term is a 3. And then your rule says, if I want to find any number of the equation, all I have to do is go back one term. So if I wanted to find the second term, I would go to the first term and I would add 4. And look at that, there's your recursive rule. You already did half of it. Now we're going to find the explicit rule. So the explicit rule is when, if whatever term you're trying to find, you take your first term, then you add the common difference times your previous term, n minus 1 term. So what we're going to do is we're just going to plug in our numbers right here. So in order to figure out my equation, I'm going to take my first term, which is 3, plus my common difference is a 4, times n minus 1. That means whatever term I'm trying to find, and go back previously. Now, this is just a normal algebra problem that I can solve really easily. I'm going to distribute my 4. So I get 3 plus 4n minus 4. And then I combine some like terms. So 3 and -4 can be combined to get me a -1. So my final equation here, my final rule, excuse me, is 4n minus 1. Now, the last thing it asks me to find is A25. That means the 25th term. Now, what I can do is I can go to the first term and continue to add 4, like 1 times, 2 times, 3 times, 4 times, all the way up to 25. Or, if you don't want to do that because that seems like a lot of work and really extra, and I'm not really all about that life, what I'm going to do is I'm just going to take this 25, I'm going to plug it in for my n term. So that's easy peasy. So I'm going to do A25 equals, so I'm going to do 4 times 25, and then I'm going to subtract 1. So 4 times 25 is 100. Think about 4 quarters. Take away 1, and you've got 99. There's your final answer. So you are going to have to know the recursive rule for the test, the recursive, excuse me, and the explicit rule. I am not going to give that to you, so you do need to make sure that you have that memorized. So something to think about. Okay, so now you're going to pause the video, and you're going to try that next problem. Okay, so now number 6. Oh my gosh, we're so close, team. 2 more problems. We're almost there. Okay. Number 6. So what you're going to do here is we're looking for an arithmetic, we're going to take this arithmetic series and we're going to find the sum of it. So that means if I asked you to go like from this last problem that we did, if I would have said like, oh, find the sum, that means you would have had to have had the first term plus the second term plus the third term plus the fourth term all the way up to the 25th term. But again, that's extra, that's a lot of work, and I can do it way easier if I know the formula. So First thing I want to do is figure out where do I start and where do I end. So this number down here is your starting point. This number up top tells you your ending point. And this over here is your equation that you're going to plug it into. So the first thing I want to find is my first term. So my first term is when I plug in the 21 in for the n. So my first term is going to be 2 plus 3 times 21. And so if I multiply these two, 21 times 3, and then add 2, I'm going to get 65. Yeah. Okay. Then my last term, a sub n, is going to be when I put in my ending number in for n. So I'm going to do 2 plus 3 times 60. And so I'm going to do 60 times 3 is 180 plus 2 is 182. Now the last part I need before I can find the sum is I need to know the number of terms. So if I start at the 21st term and I end at the 60th term, I need to know how many terms is that. Well, you could sit here and count 21, 22, 23, 24, and like so on and so forth, but that's a lot of work. So what I'm going to do is you can just take these two numbers, you can subtract them, and then you need to make sure you add 1 at the end because you have to include the 21st term. So if I do that, I get 40. Now, I have my 3 pieces of information, so I'm going to plug them into the arithmetic series, the sum equation. And the sum equation says, in order to find the sum, all you have to do is you take your n number of terms and you multiply it times your first term plus your last term divided by 2. So essentially, you're finding the average of these two and multiplying it, or excuse me, average of these two, and multiplying it times the number of terms. So I just got to plug it in. So my sum is 40 times, I'm going to add 65 plus 182, and I'm going to divide it by 2. I'm just going to find the average of those. And so if you input that into your calculator, you're going to add these two, divide by 2, then multiply by 40, you will get 4,940. That was probably way less work than me trying to add all of those terms together. Okay? Again, another thing you're going to have to know for your exam, I am not going to give you this formula, so you have to know arithmetic series, the formula. So now you can try this problem here. And so this is, it's kind of hard to see, but that number at the bottom there is a 5. This number is an 11. Okay, and then it's 2m squared minus 2. So give that one a try. All right, last problems we're going to do now are some imaginary and complex numbers, because I think that a lot of us forgot maybe some of like the really important rules here. So one of the things that I need you to remember when it comes to imaginary and complex numbers is that if I take I squared, if I square that, I'm going to get -1. You've got to remember that. Now, I'm going to simplify these imaginary numbers here. So for my first problem, I've got 3 minus I over 6i. Now, I am not allowed to have an I in the denominator. So in order to get rid of the I in the denominator, I'm going to multiply the top and the bottom by I, so I can get rid of it. Okay, so I'm going to multiply the top by I. So I distribute I to this whole thing. So 3 times I is 3i. Negative I times I is negative I squared. And at the bottom, I've got 6i times I is 6i squared. Now, I remember that I squared is -1. That's why I made us write this. So I'm going to simplify the top. I've got 3i. Now, if I've got I squared, that's -1, and a -1 with a minus sign is going to become a +1. 6i squared, well, I squared, remember, is -1, so 6 times -1 is -6. So if I look at this, I can't reduce those numbers. They don't all have something in common, so I'm done. However, you need to make sure that if you're writing it in standard form, that you put the real part first. Okay, so maybe you need to write that down. This means real part is first. So if I'm doing the real part first, I want to put 1 plus 3i over negative 6. And that's going to be my final answer. Okay, so now let's try letter B. Letter B is a little bit different because now I don't just have an I at the bottom, I have a 2 plus I. So in order to get rid of a 2 plus I want to multiply by its conjugate. And conjugate means you take the bottom and you change the sign. So I'm going to multiply this by 2 minus I on both the top and the bottom. So I'm going to start by doing just the top first. Because this, my friends, my little gems, is a FOIL problem. So I need to make sure I FOIL it. So first is 3 times 2. That's 6. Outside, negative 3i. Inside, negative 2i. And last, positive I squared. So let's just clean that up a little bit. I can combine some like terms right here. So negative 3i minus 2i is a negative 5i. And then I squared is a negative 1. And then I can combine a 6 and a negative 1. And I'm going to put that first because I remember that the real part goes first. So I'm going to put 5 minus 5i. Now that's just the top. Now we have to do the bottom. So again, it's FOIL. First, outside, inside, last. Okay, now, again, these two can be combined, but actually what's going to happen there is they're just going to cancel out. I squared is a negative 1 minus a negative 1 is really plus 1. 4 plus 1 is 5. So my fraction now looks like 5 minus 5i all over 5. Now all three of those can be divisible, divided by 5. So if I divide all three of them by 5, I get 1 minus 1i, and I don't need to put it over a 1. You can if you want to. You don't have to, but that's your final answer. Okay, last problem. We're so close. Okay. Again, this is a problem with the minus sign, and it's got an I in the bottom, so I'm going to multiply by the conjugate. So I'm going to multiply by 3 plus 5i, 3 plus 5i. And just like the last problem, I'm going to do a top and a bottom so that I don't get myself confused. So let's start first just with our top. So first is a 3. Outside is a 5i. Inside is a negative 6i. And last is a negative 10i squared. Okay, so let's combine some like things. These two can be combined. That's a negative I. I squared is a negative 1. Negative 10 times negative 1 is a positive 10. Combine my numbers, my constants. 13 minus I is the top. Now let's do the bottom. So first, outside, inside, and last. Okay, my center numbers are going to cancel each other out. I squared is a negative 1. Negative 25 times a negative 1 is a positive 25. And 9 plus 25 is 34. So now my final answer is 13 minus I over 34. And they don't have anything in common that I can reduce that with. I put the real part first. There's my final answer. And I'm done. So now your last question, my babes, my beauties, you are going to simplify the imaginary and complex numbers, and you're going to make sure you write it in standard form. And then once you are finished there, you are finished and all set for your exam. So congrats. Thanks for watching my video. And apparently I'm supposed to give a shout out to Colin. So shout out to Colin. There you go. I hope you're happy. Love you all. Have a grand day.